to then go here and say, look at that. There you go. Perfect. At least it's recording. Okay. And then I'll just do this. Okay. This test review, I'm going to have to go back and look through this. This is you're going to lose it. There's too many questions. A young Johnny made this test review back when I was more ambitious. Okay, so let's see. This is going to be one for maybe about 1.5. It's asking, and these are your favorite, right? To find the equation of tangent line. On the equation of the tangent line, and it is for the function, easy function, negative x cubed, and there's a point of negative 2, 8. Hey Siri, remind me to make sure that test 2 and the review for BCal align, and that hey Siri, remind me to schedule the test for BCal. Hey Siri, remind me to open 1.7 homework. If y'all would be good students and email me when things are missing, I wouldn't have to I'm just kidding. I'm sorry. You shouldn't have to email me. It should be there. Okay. So the wording usually scares people. Find the equation of the tangent line. I usually like to remind myself or remind you all that we're going to be using what's called this point slope formula right here, and it requires a point, an xy coordinate, which we already have. And it requires a slope, and we don't quite have that yet. We're going to use the calculus to find that slope. I've got this all for me here later, and I'm just going to kind of forget about it, and I'm going to focus on the calculus. I've just sort of helped myself out for later. It's there later. So let's do the calculus. All I have to do is take the derivative, and the derivative of negative x cubed. I'm going to let you take that derivative, and I'm going to walk around and see how healthy we are with these derivatives. Okay, what I'm seeing, I'm liking. What I'm seeing, I'm liking. Okay, so the derivative of negative x cubed. Remember, you have the negative 1 out front, that constant. So we just sort of copy paste it, bring it down, the power 3, bring it to the front. Okay, so you're saying negative 1 times 3, your variable, and you're raising it to the power of 3 minus 1. So that derivative is negative 3x squared. A lot of you, most of you, I was able to see that you skipped like this manual step and you went straight to the derivative. That's the goal. Simply because we want to get, when you're quicker, it gives you more confidence, and then you're more confident for the other complicated looking things, okay? So this is the derivative, but it's still not the slope. you use the derivative to help find the slope. So what we want to do is, that derivative has an x value in it, right? We have a point with an x value in it. We're going to put that x value from the point into the derivative. We can notate that as f prime of -2. And so -3 times -2 squared is what we're finding. -2 squared is 4. 4 times -3 is -12. So I have everything I need for this point slope formula right here. Y minus y sub 1, the y value from the point is 8, okay, equals the slope that we found of -12, and then x minus the x value of -2. And from here, you can make this step as long as you can make these go on for days. You're just getting rid of the parentheses, distributing the 12, and to get the y by itself. Wait just a second, that was minus a negative. This is -12, and so this is minus 144. And so now you're just going to add 8 to both sides to get that y equals -12x minus 136. I'm not really good at math in my head.
Dang, it's supposed to be a +2 instead of +12.
Yeah, what'd you?
Okay, what?
X minus -2.
Oh. Okay, see, I'm going too fast. Another good, confidence is good, but then you get, too confident and do dumb stuff. Okay, so, that's a 4 times. Okay, 4 times 12, 8, -48. Yeah, -48 plus 8. Oh, okay, that's better. Would you get -40? Let me get a calculator. I need a calculator. Okay, so, y'all, let's back up. Right, because you get redos in life sometimes, not always. But right now we do, because this is dry erase. Okay, so that point is -2. That is in there correctly. The slope is -12. The y is, yeah, that's right. Y minus 8 equals -12x. Now, this is going to be +2. +2 times -12 is -24. Do we agree? Do y'all see anything? I'm not being whatever. I'm actually being that way towards me.
Looks good.
Okay. I'm just scared. I'm scared to do something dumb at this point. Yeah. Yeah, okay. There we go. This is the equation on the line. Okay, see what I was talking about when most people can do the calculus but screw up on the algebra? Forgive me, I'm so sorry. I know that was traumatic. Let's, do a derivative now. Just a plain derivative problem. This is an application problem that we just did. Any questions about it before I erase it? Okay, this is also going to be from 1.5 as well. Okay, so, and this is where the game that I was trying to get us going, that's why I walked into the class late. This is where it would have really helped out because I really want to walk around at the moment and watch you take the derivative of this. So it's saying find y prime when your y is the square root of 10x. That thing I was going to do is something that we could have done on our phone, and you would like be able to scratch what the answer is, or like scratch the first step, and no one would know who did it, and I could see it, and it'd be, yeah. Anyway, whatever. On problems like this, though, we're just finding the derivative. What's the first thing I want to do before I even do any calculus? This is y equals the square root of 10x.
10x 1/2.
What do I want to do? Write it to the, yes. See, I can't hear anymore, I'm sorry. Rewrite it as 10x to the 1/2 power. Generally, in this class, I'm going to take any radical and rewrite it as a power, as a fractional exponent. Okay, so now that I've rewritten it, I can use the power rule. I can, y'all, let me see if I wrote this problem down right. This is not 1.5. This is 1.7. This is a chain rule. Because, so when I first diagnosed this problem, even when I wrote it here, I was thinking it was going this direction. And this is a plain power rule. But I guess I could still, whatever, we're going to do the chain rule on it. It works either way. One half times something to the negative half. Plug in your inside and then multiply by the derivative of the inside. So this is a problem like what we would have finished up, what we were looking at on Tuesday, a chain rule where we have the inside and the outside. The derivative of the outside, put your inside back and multiply by the derivative of inside. Now usually on these problems we can multiply the front and the back together to give us 5. And then if you wanted to keep going and make it look even better, you could put the square root of 10x in the denominator if you wanted to. I will accept this though. I will accept that. Let's do something refreshing. I thought that one was going to be refreshing, but I just glanced. I didn't actually read it whenever I wrote it down. So sorry, it wasn't as refreshing as I wanted. Right here we have y equals x to the 5th. So if I want to do y prime, that's 5x to the power of 5 minus 1. This is just a simple chain rule. So yeah, there will be problems like this on the test where we have something just plain refreshing and we're done. You're going to have something like this where it says find y prime if or when y equals 7. So what's the derivative of 7? 0. Yeah, so you're going to have things that, and believe it or not, that, problem right there counts just as much as the one that, caused you to go to therapy. So there's several of these, like those two sort of that I'm just skipping through. Let's level up. And let's see. Okay, this time we're going to say f of x equals. What time is it, y'all?
11:17.
Okay, so for x, don't let me go past
11:20.
11:25. But remind me at 11:23.
Okay.
4x cubed minus 13x squared. 4x cubed minus 13x squared. I'll just leave it there. Let me do another plus 35x. So when they're just simply added or subtracted together, I can take the derivative of each part. So that is 12x squared. Just doing a power rule, and we're doing another power rule. The negative 13 gets multiplied by the power of 2 to give us negative 26, and we raise x to the power of that 2 minus 1, so it's just going to be the first power. And right here on the end, the derivative of 35x, 35. Just 35. I bet you I am extending this test till the next week. As much as I don't want to, I like to try to be ahead. And my brain gets to thinking when I'm on schedule, like when there's not really on schedule in my brain. There's on ahead or a behind. And so it just messes with me to have to push it back, but that's okay. Let's do this. Y equals 8x to the 4th minus x plus 2 times negative x to the 5th plus 9. Negative x to the 5th plus 9. Okay, it's really sad how I forget what I'm writing down in the span of looking here to there. I don't know what is wrong with me. Okay, so this is a product rule. You have a function times a function. This is your first function, your back function. And I like to, well, you could go ahead and write the rule down. And this is sort of a sloppy, not formal version of the rule. I don't have it formally written out here, but that's a note right there. F times G prime plus G times F prime. Since we're not testing on Thursday, I've already decided that, we are going to have a quiz. And I'm quizzing you on the formulas for product, quotient, and for chain rule, you can either write the formula down or write the sentence down that I gave you. And I'll write that down for you in just a second. I don't need you to call it, f of x times g prime x. You can write it just the way I write it. Just the way I write it is fine. Okay, but the derivative of the first function is 32x cubed minus 1. The derivative of the second function is negative 5x to the 4th. So now, when I take the derivative of y, I'm just gonna copy paste all this information into the formula. So the first function was 8x to the fourth minus x plus 2. The derivative of the second function was negative 5x to the fourth. The derivative of the first function, the derivative, pause. I've already written down the first function now, and then I wrote down its derivative. I need to stop. Can't say anything right today. I've written down the first function. I've multiplied by the derivative of the second. Now I'm about to write down the second function. Copy paste the second function, which is negative x to the fifth plus 9. And then I will write down the derivative of the first function, which was 32x cubed minus 1. Take a look at that and see if there's something that you disagree with. I think that I have it right. Wait, first function, derivative of the second. Second function, derivative, yes, that's right. This is the calculus. This is the step I have to have. This is the step that if you don't get here, you get no credit. Okay? You actually, if you get this exactly, you get full credit. And then if you keep going and keep going correctly, I can give you some I appreciate this credit that will potentially offset some mistakes or, a more complicated problem, okay? So let's keep going with this. Anything that you can do with, please excuse my dear Aunt Sally, anything we can do to simplify further, let's try to do that. So negative 5 times 8 is negative 40, and then your x to the fourth times your x to the fourth that we need to do is x to the eighth. Keep the base and add the exponents together. Now it's a negative x times a negative 5, so that's positive 5. X is now to the fifth, okay? And then a positive 2 times a negative 5 is negative 10, just x to the fourth. Then, okay, so this is needing to be FOILed. So, negative x to the fifth times 32x cubed is negative 32x to the eighth. And negative x to the fifth times negative 1 is positive x to the fifth. Now I will need to distribute, I need to make that look like a 5 instead of an S. I need to be better with my 5s. Now we will distribute the 9. I have no idea what 9 times 32 is.
288.
280. Please don't be sarcastic. I'm just kidding. 288. Let's see. 288 x cubed, and then 9 times negative 1 is negative 9. So from here, like terms, I see the negative 40, the negative 32. That will give me negative 72, right? Yeah. X is to the eighth. And then 5x to the fifth plus x to the fifth is 6 of those x's to the fifth. There's an 10x to the fourth, just the negative 10x to the fourth is all I see. The x's to the fourth. 288 x's cubed. It really bothers me that there's no x squareds or x's. It just really is killing me. I would probably rewrite the problem just because it's bothering me. But I don't see it, so we'll just trust it and say minus 9. What time is it?
25.
Mother. Okay, let me write those formulas down. There's one of them at the top right corner. That's the product rule. Quotient, and so that goes if you have to take the derivative of an f times a g, okay? If you need to take the derivative of a numerator divided by a denominator, then its derivative is the denominator times the numerator prime minus the numerator times denominator prime all over the denominator squared. So this is quotient, this is product, and this is chain that we're about to write down. Now, the chain, I don't really know of a way to write it less formally. If you need to take the derivative of a f of g of x, then it is, bless you, f prime. So the derivative of the outside, write your inside back down and multiply by the derivative of the inside. I usually don't write that formula down when I use it. My brain, and since what's better for my brain, I'll let you use what's better for my brain if you would like, and that's this sentence. Derivative of outside times derivative of inside. That is the exact sentence I will take. That sentence could be better where it says times. It would be better if I said derivative of outside, put your inside back in, and then multiply it by the derivative of the inside. But times, this just flows off the tongue, right? That flows off the tongue better. I just have to know where I say times right there. That means, because if I literally do what the sentence says verbatim, that would be so that I'm really leaving out a few words that tell me to put the derivative, to put the inside back in, but hopefully you will remember to do that. Okay. If I do not open the homework, like today, tomorrow, like I need emails. I say I need emails. You need to email me for your benefit because you need to be working on and practicing that 1.7 homework. That is not open yet. And I'm going straight from here to a meeting and straight from here to like doctor's appointments and back to back. So I bet you I don't remember to open 1.7.
So we got 2 due at the end of the week?
1.6 was already due today or last night, I believe.
Yeah, I think.
I'm going to take a look at what was in that, and I might add some to it. If I think 1.6 was good as is, I'm just going to give you 1.7 and open the test review as well, and let you know. So that's probably what will happen is just a 1.7 and a test review. Okay. Y'all have a good weekend.
Trip, so can I come Wednesday and take a laptop or quiz for the formulas?
Don't worry about that. Just make sure you know these formulas.
Okay. Wait, I can send you
No, I'm not worried about it. Like I'm just trying to make people memorize them. That's what I'm trying to do. I'm not trying to give you all like an extra hard grade or something.
Okay. Have a good rest of your day.
Yes, ma'am. Well, I know you were out some, so if you need anything, and this system has not been working the best, so please let me know if you get something, like if you get somewhere in a homework and you're like, I really wish I had, let me know what that is. Whether it be more time, another video, to sit down with me, please let me know.
Yes, sir.
And even if, like I want to take the test when everyone else takes it, that's what's going to be best for us, like just for you moving forward. But if for some reason you can't, like if for some reason you just need more time, just let me know, okay?
Okay. Thank you.
Yes, ma'am. I'm sorry. I hope I don't put extra work on you.
No.